Very good morning to one and all. The last class we discussed about the coining, heading, and piercing, the three important forging operations. And today in this class we are going to discuss about the die design, because in order to fabricate or in order to get the forged product, the die design is one of the very important steps. And we also will go through what you understand or mean by preshaping, and we will also go through the design features, dye materials, and we finally discuss about the lubrication in forging process. Today let's start with the die design. So the proper die design is the important step in the success of forging design, like the pre-shaping and the pre-form design is the most difficult and critical step in the forging die. The design of forging dies, it requires the knowledge of shape and complexity of the workpiece, its ductility, how much ductile it is, I mean it's a material characteristic, its strength and sensitivity to deformation rate and temperature, and its frictional characteristics. So the design of forging dies, a designer have a thorough knowledge of all these aspects, and also at the same time he or she should be familiar with the distortion of the die under high forging loads. So when the die is subjected to high forging loads, how much deformation it undergoes. The If you talk about the die design, the first step in the design of forging die is the decision regarding what stages are necessary for achieving the required shape and strength for the forging. I mean, so usually or normally the fullering, edging and finishing impressions are needed, because while learning about the basic operations used in forging process, we are familiar with these techniques, and then additional operations such as blocking, bending and flattening impressions are also used as per the requirement of the product design. So that is the first step. What stages are necessary for achieving the required shape and strength for the forging? And the most important rule in the die design is the fact that you should underline this point: the part will flow in the direction of least resistance. So this rule must be kept in mind when you are going for a die design. And nowadays the software is available to help predict material flow in forging die cavities. You can also make use of the simulation softwares in order to predict the material flow in forging die cavities. Yeah, this is what I told you about. That's one of the main steps in a die design. That's what stages are necessary for achieving the required shape and strength. Now let's these are the two important steps, like the pre-shaping and preform design. The pre-shaping in forging, it is similar to the pre-shaping of duff into a spherical form to make a round chapati correctly. So that maybe you can connect this pre-shaping operation in a forging with this, so that you may get a easy understanding of what do you mean by pre-shaping. So in a properly pre-shaped workpiece, the material should not flow easily into flash. So otherwise the die filling will be incomplete. Again, the grain flow pattern should be favorable, and again there should be minimized sliding between the work die interfaces. So these 3 points you must keep in mind. The material should not flow easily into a flash, the grain flow pattern should be favorable, minimize the sliding between work die interfaces. The selection of shapes is based on the calculation of cross-sectional area at various locations in the forging, as well as based on previous experience of the designer. And nowadays the CAD techniques, computer aided design techniques, are now available. To predict the material flow pattern in the die cavity and to predict the formation of defects. Yeah, the proper preform design assures the defect free flow, complete filling of the die, and minimum loss in flash. Next, we are going to discuss about the die design features. Please have a look at the schematic diagram which I have put in this slide. The terminology for forging dies is shown in this figure. You can see different like parting line, draft angles, webs and ribs, gutter, fillet radii, corner radii, trim line, land. So you can see different type of nomenclatures. We are going to discuss in detail what all these nomenclatures denotes. So first one would be the parting line. So it is a plane that divides. If you look at the diagram, you can easily see that it is a plane that divides the upper part of the die from the lower part. So this line is also called a flash line. And the selection of location of the parting line, where the parting line is located. So the selection of location of the parting line affects, first one, the grain flow in the part, the required load, the flash formation. So for most of the forgings, the parting line is located at the largest cross section of the part. So it is the place where the parting line is located. The parting line is located at the largest cross section of the part. So wherever possible, it should be a straight line along the center of the forging. So that's a design criteria. Wherever possible, it should be a straight line along the center of the forging. And for example, if you have an asymmetrical shaped part, the parting line is normally a straight line at the center of the forging. But for complex shapes, the line may not lie in a single plane. The second nomenclature you can familiar with is a draft angle. So this draft angle are necessary in almost all forging dies. Why? In order to facilitate the removal of the part from the die. Yeah, in order to facilitate the easy removal of the part from the die. The draft angle means the amount of taper on the side of the product to facilitate easy removal from the die. For example, if we are working with the steel forgings, the draft angle should be 5 degree to 7 degree, and for aluminum and magnesium forgings, it is 3 degree. So for precision forgings, the draft angle is nearly 0. You know what is meant by a precision forging. What does it mean for? Yeah, to facilitate easy removal the internal draft angles are made larger than the external ones. The internal draft angles are of the order of 7 to 10 degree, whereas the external angles are of the order of 3 to 5 degree. The next one we are going to discuss about the webs and ribs. So the web is a thin portion parallel to the parting line. You can see the web. This is called the web, and similar the rib. This is called the rib. So the rib is a thin portion perpendicular to the parting line. So the web is parallel to the parting line. The rib one is the one which is perpendicular to the parting line. Next we can see what do you mean by a fillet and corner radii. What do you mean by a fillet and corner radii? Again, if you look at the diagram, the selection of proper radii is very important, because in order to ensure the smooth flow of the metal into the die cavity, the small radii is generally undesirable because it tends to limit the metal flow and increases the stress on the die surface. So please note that the small radii, the radii is not recommended. Similarly, small fillet radii can cause fatigue cracking of the die. So in general, what I can say is radii need to be as large as permitted by the forging design. The next we are going to see is the flash. Flash, as you all know now, what do you mean by flash? The formation of flash facilitates the pressure buildup inside the die. So when the flash material come out, it seals the space between the die and the component, and it facilitates the pressure buildup inside the die and promote filling of the cavity. The next one would be land. If you look at the diagram again, you can see that where is the land is placed. You can see that why this land is provided here. So it determines the surface area along which the lateral flow of the metal occurs. So hence it controls the pressure inside the die. Another feature is the gutter. You can see that where the gutter is provided, it's a provision for excess metal to escape without affecting the forging loads. So it's a provision provided here in the die design for the excess metal to escape without affecting the forging loads. Now another important topic, you have to be familiar with the die materials. So it is well known that most of the forging operations, particularly for medium and large parts, carried out at elevated temperatures. The most forging operations are carried out at elevated temperatures. So let's see in this context what are the general requirements for die materials. One is the strength and toughness at elevated temperatures. The material should exhibit very good tensile strength, impact strength, flexural strength properties. Of course, the toughness at elevated temperatures. The second point would be the hardenability and the ability to harden uniformly. The third point would be the resistance to mechanical and thermal shock, resistance to impact loads, and the last point would be the wear resistance, particularly resistance to abrasive wear because of the presence of scale in hot forging. And the selection of proper die materials, it depends upon many factors which I have not included in this slide, but you may note down. The one would be the die size and the composition and the properties of the workpiece. What are the elements which constitute the workpiece? Third point would be the complexity of the shape, the forging temperature, the type of forging operation adopted, the cost of the die materials, the number of forging requirements. So based on all these factors, we select the die material. I shall repeat once again, what is die size, the composition and properties of the workpiece, the complexity of the shape, the forging temperature, the type of forging operation, the cost of the die materials, and the number of forgings required. And again, another important factor is the heat transfer from the workpiece to die. So based on these factors, the die materials are selected. And what are the common die materials? If you look at here, I have highlighted it here. Two and die steels containing chromium, nickel, molybdenum, and vanadium are typically used as the die materials. And these dies, the forging dies, are made from the die blocks. Actually, these die blocks, which are forged from the castings and then machined and finished to the desired shape and surface finish. Again, another important which I have not included, but you may please note down. I told you usually the tool and die steels containing chromium, nickel, molybdenum, and vanadium are commonly used as die material. When the percentage of this chromium, nickel, molybdenum, and vanadium, how does it is going to affect the die? For example, if the purpose of adding chromium, generally the chromium is added from 0.5 to 4 percentage. So this is added to increase the high temperature strength for the die material. And the nickel, the composition varies from 1 to 5 percentage. It is adding to impart the toughness and impact strength. Then vanadium varies from 0.1 to 0.3 percentage. It contributes to improved wear resistance and fatigue. And tungsten varies from 2 to 3 percentage to enhance the effect of other elements. So the common range of hardness for dies is 340 to 375 BHN, Brunel hardness number. And I told you the machining of die blocks is required to make the die. The machining of die blocks can be done by electro discharge machining or EDM, on electrochemical machining or ECM, which are the very popularly used technique for making the die blocks. Another important title in the lubrication in forgings. Why we need to use lubricants? As we all know, the lubricants greatly influence friction and wear. So consequently, they affect the forces required and the flow of material in die cavities. They also act as a thermal barrier. Between the hot workpiece and the dies. And again, it prevents the sticking between the dies and the workpiece, which means it serves as a parting agent. So these are the three things you should remember. One, the lubricants greatly influence friction and wear. They affect the forces required, die life, and the manner in which the material flows into the die cavities. It acts as a thermal barrier, parting agent. The commonly used lubricants in hot forging are graphite, molybdenum sulfide, glass, etc. And for cold forging, the mineral oils and soaps are also used. So that here we come to the end of this lecture. So let's look into what are all the things we discussed today. We discussed about the die design, and then we discussed about the important steps, pre-shaping and preform design, and we also go through the die design features such as parting line, draft angle, webs and ribs, fillet and corner radii, flash, land and gutter. We also get familiar with the die materials and another important topic, lubrication. Thank you.